Pipe welding is a process that ensures the longevity and safety of piping systems. A pipe welder joins sections of pipes to create a continuous pipeline. They are responsible for welding various types of pipes, including steel, copper, and plastic, using different welding techniques. Pipe welders work in various industries, including construction, manufacturing, and oil and gas. Pipe welders usually use one of the following arc welding processes. Shielded metal arc welding, SMA. Pipe welding often uses the shielded metal arc welding, SMA, technique, commonly called stick welding. This method uses a stick-shaped electrode to generate an electric arc that melts the metal during welding. The welder uses a flux-coated electrode to protect the weld metal and prevent atmospheric contamination. SMA is a versatile process that a pipe welder can apply to various metals, including carbon steel, stainless steel, and cast iron. Gas metal arc welding, GMAW, is a process that uses a continuous wire electrode to weld metal. The arc between the electrode and the workpiece heats the metal, causing it to melt and join. GMAW is a versatile process that can weld various metals, including carbon steel, stainless steel, aluminium, and magnesium. It is popular for welding pipes because it is easy to use and produces a high-quality weld. To weld pipe with GMAW, you will need a welding machine, a welding gun, a wire electrode, and shielding gas. Flux cord arc welding, FCAW, is an exceptional welding technique that employs a tubular electrode filled with flux instead of a solid wire. The flux safeguards the weld area against atmospheric contamination, while also imparting additional elements to the weld to enhance its quality. FCAW is versatile enough to weld various materials, including carbon steel, low alloy, and stainless steel. To perform the task, you only require a steady voltage power supply and a wire feeder to move the electrode to the welding point. Submerged arc welding, SAW, is commonly used for welding low and high alloy steel and carbon steel pipes. It involves creating a welding arc submerged beneath a flux layer, protecting the weld pool from atmospheric contamination. The SAW process requires a constant voltage power source and a wire feeder that delivers the welding wire to the weld joint. Submerged arc welding effectively welds pipes of different diameters, thicknesses, and lengths. Tungsten inert gas, TIG welding, also known as gas tungsten arc welding, GTAW, is commonly used in pipe welding to weld stainless steel, aluminum, and other non-ferrous materials. TIG utilizes a non-consumable tungsten electrode, which creates an arc with the workpiece, melting the electrode and the base metal to create a weld pool. A filler metal is added to the weld pool to create a durable weld. TIG welding requires a constant current power source and an inert gas, such as argon or helium, to shield the weld area from atmospheric contamination. One of the main advantages of TIG welding is its ability to produce a clean, precise weld with minimal heat distortion. It can also weld fragile materials, making it well-suited for thin-walled pipes. Pipe welding steps. Pipe end cleaning. To ensure a good quality weld, the surfaces to be joined must first be cleaned. Before welding can start, the pipe must be free from moisture, coating, rust, oxides, and other contaminants to prevent defects and costly repairs in the future. Aligning the joint. Aligning the joint is critical for a successful welding application. A line-up clamp is ideal for this process, as it securely holds both ends of the pipes in place to maintain correct alignment. Backing rings. A backing ring is a device that helps prevent the weld from penetrating too deeply into the pipe wall. It prevents any metal from entering the ID of the pipe through a burn-through or spatter sprayed around during the welding. This allows the weld to penetrate only the outer surface of the pipe, leaving the inner surface unwelded. Backing gas. Backing gas is a type of gas that is used to protect the backside of the weld from atmospheric gases during the welding process. It is commonly used in welding processes such as gas tungsten arc welding, GTAW, and gas metal arc welding, GMAW. The purpose of backing gas is to prevent oxidation and other atmospheric contaminants from entering the weld area, which can negatively impact the quality and strength of the weld. In GTAW, welders often use argon gas as a backing gas. Backing gas is an important consideration in welding, as it can greatly impact the quality and strength of the final weld. Tack welding. Tack welding is a form of spot welding where two metal pieces are joined using small temporary beads of molten metal. The number of tacks required depends on the pipe diameter, with larger pipes potentially requiring up to 8 tack welds. This technique holds the pipes securely without affecting their alignment due to shrinkage caused by root passes. Welding, pipe welding, is a specialized practice that requires careful preparation and consideration of materials, electrodes, and welding parameters. When welding starts, you must perform the initial passes, known as the root pass, followed by a hot pass, before proceeding to the filling and final cap passes. Pipe welding passes. The welding passes refer to the order of execution required when carrying out the pipe welding process. The 4 passes typically used in pipe welding include the root pass, hot pass, fill-up pass, and capping. Root passes. A root pass is the first step in any welding process and involves joining 2 pieces to form one structure. In this step, we heat the filler metal to an exceptionally high temperature and pass it through the gap between the pipes. Utilizing the root pass requires more expertise than the following passes, so it is essential to exercise caution. In order to complete the weld pass, you must keep the root face smooth and uniform. If there are any imperfections on the weld face, you can correct them by grinding it out, so it does not have to be smooth or uniform initially. Hot passes. When completing a butt weld, the hot pass is the second phase, which involves using higher amperage to produce a hotter weld. This helps to eliminate any impurities left behind by the root pass, resulting in a flatter and more uniform weld. The hot pass is also known as the welding pass and is used to connect the root weld to both faces of a pipe. By heating and joining the area around the root weld with the pipe's face, this process can quickly remove any trapped slag that traditional chipping and wire brush methods cannot. Fill passes. The filler passes are the intermediary steps in welding pipe joints. This involves making a series of weld passes and filling the groove with molten metal. The welder can make the filler passes using a series of stringer beads or a weave bead, depending on experience. Stringer beads require less metal to be molten at one time and are therefore simpler for beginner welders to perform. After completing the filler passes, the welder has properly welded the joint. Cap passes. The cap pass is the final stage of welding a pipe joint. It requires a thin weld with minimal buildup beyond the surface. To achieve optimal strength, the welder must perform good beading and remove any contamination before completing the cap pass. You should also clean up the weld edges and use a file to remove any spatter. Electrodes used. For pipe welding, you can use either E6010 or E6013 electrodes for the full weld or to perform the root pass. Use E7018 electrodes to finish the joint. There are 4 pipe welding positions: PA position, PC position, PF, and HL045/JL045. To ensure safety while performing pipe welds, welders must be certified in each position before taking on different poses. Consequently, someone with a qualification in PA cannot weld PC, PF, or HL045/JL045. Only those with HL045/JL045 certification are eligible to attempt any other pose. Welding position requires good control and dexterity from the welder to maintain proper electrode angle and weld bead shape, prevent weld spatter, and ensure proper weld penetration. PA welding, also known as 1G welding, is a position where the workpiece remains stationary and the welder rotates around it to create a weld. In this position, the welder performs a 360-degree rotation around the workpiece, evenly distributing the welding material and forming a strong and secure weld. When performing PC welding, also known as 2G welding, the welder holds the components stationary while placing the pipe in an upright vertical position and allowing it to rotate along its y-axis. The welder performs the welding horizontally on the side of the pipe, using heat and pressure to join two pieces of metal. In PC welding, good agility, control, and physical endurance are required from the welder to work in an overhead position for extended periods, are necessary for this welding position. PF welding, also known as 5G welding, is where the pipe is placed horizontally and the welder moves around it vertically to create the weld. This method eliminates the need to rotate the pipe, which can be difficult or impossible in specific welding scenarios, and allows for more accurate welds with less effort. The vertical movement of the welder in the PF position also requires physical endurance, as the welder must be able to work in a confined space for extended periods. HL45 is a method used to weld pipes at a 45-degree angle, also known as 6G welding. This welding position requires more expertise from the welder than 5G welding, as the welder must move around the pipe while maintaining a fixed position. Highly experienced welders usually perform the HL45 welding position, which is considered the most complex of the 4 welding positions. The HL45 position is uphill, whereas JL45 is downhill. Additionally, due to the angle of the weld, the welder must prevent gravity from affecting the weld pool and maintain proper welding techniques to ensure a strong and secure weld.